What's up, fellow tech geeks? Welcome to Bauer Power. Today we're going to make a Wi-Fi connected automatic pet feeder because my cat is fat. She needs some Jenny Craig. Stick around. Alright, what you're going to need is a dry food dispenser, a D1 Mini or any of the development boards that run the ESP8266 chip, a servo motor, the SR04 ultrasonic sensor, a buck converter. I used a buck converter because I don't think just a regular USB cable can support the current that the servo motor is going to demand. Let me know if I'm wrong or if you have any input on that down in the comments below. A solderable breadboard, an AC adapter. I had one laying in a drawer, so I didn't need to buy one. And of course, coffee. As far as tools go, you'll need a soldering iron, of course, a set of diagonal cutters, some wire strippers, not those kind of strippers, you weirdo.
Alright.
And that's pretty much it. We're going to start off by creating a binary file in ESPHome so we can flash it to the D1 Mini in order to get it connected to our Wi-Fi. Click the plus sign at the bottom right and give it a name using their naming conventions. Choose the chip that you're using from the drop-down menu. Enter your Wi-Fi credentials and over-the-air password. Once you've added the sensor, click the three dots on the right and choose Compile. Once compiled, download the binary file to your hard drive. This was my first time using the D1 Mini on my computer, so my computer didn't recognize it. So I had to download drivers and install those in order to get it to work. I'll include a link down in the description, in addition to links for all the parts that you need for this project. They're Amazon affiliate links, so if you use my links down below, I think I get like 5% commission. Thanks for the support. In order to flash the binary file onto the board, you'll need a flash utility. If you don't already have one of those, I'll include that link down in the description too. If you're using the same flash utility as me, under the config tab, click on the gear icon on the right and browse for the binary file that you downloaded. Once you're all set up and your D1 Mini is plugged in, click on the flash button. Once the D1 Mini is flashed and rebooted, the header in ESPHome should turn green, and that shows that it's connected to your Wi-Fi and it's communicating. Now let's modify the ESPHome file to support the servo motor. Go to ESPHome.io and click the miscellaneous components on the left and you'll see the servo in the list. You'll need to copy the code from here to your ESPHome file and modify it from there. There are also a couple of things you need to do to your config and automation YAML files and Home Assistant to get it to show up in there, but it's not too hard. I'll walk you through it in just a minute. Alright, we'll start with the automation YAML file. This is the code needed to create a servo control. Basically, whatever the entity input number servo control is set to will tell the ESPHome what position to turn the servo to. Now, I had issues with this. You want the name after service ESPHome to match the device that you created earlier and then have control servo after it, just like mine here. Next, we'll tweak the config YAML file to include the servo control input. This creates a slider like a dimmer switch in Home Assistant that you can use to control the servo. I also changed my steps attribute to 10 since I don't need it more precise than that. And lastly, we'll update the YAML file for the device in ESPHome to support the servo. Most of this stuff is already in there from when you created the binary file, but you'll need to add the services under API for it to control the servo. And on the bottom, after the OTA password, is where I put the actual servo control code from the servo page on ESPHome. This is where you assign what pins on the D1 Mini is used for the pulse width modulation, or PWM, to control the servo to. Once your file is updated, go ahead and upload it to the D1 Mini over Wi-Fi by clicking Upload. Give it a little bit to do its magic, and you should be all set on the software side until we add that ultrasonic sensor in a little bit. Alright, as far as hardware goes, here's a quick wiring diagram that I threw together just to show you the big picture of how it's all wired up. Let's do some soldering. I'm adding header pins to the D1 Mini so we can solder it to the breadboard. These header pins come with the D1 Mini. It was a 5-pack that I bought, and it came with a whole bunch of different header pins, different sizes and whatnot. It's crazy how powerful and inexpensive these little chips are. We're living in the future. I'm blown away. For getting power from the buck converter to the breadboard, I soldered up some jump wires to through the through holes on the outside. And if your pin ends up a little crooked, like mine did, all you got to do is remelt the solder and you can straighten it right back up. Now for attaching the AC adapter to the input on the buck converter, you want to kind of be careful when you're stripping the insulation off the outside because the ground wire is actually like coaxial. And it forms a ring around the center positive wire, so it's easy to cut the wires accidentally for the ground. Now for some more solder and a couple snips to the extra little bit that's hanging off, and it's all set. And since these buck converters are adjustable, I busted out the old trusty multimeter just to check the output to make sure that we're getting all the voltage that the AC adapter has to offer. I set up the circuit on a prototyping breadboard just to test it all out before I soldered it up permanently. Looks good. Now for the permanent installation on the breadboard. First I attached the D1 Mini. I show a lot of details in the next clips and it might get boring, but I wanted to share enough to allow anyone to be able to do this regardless of their skill level. So feel free to increase the playback speed on YouTube or skip ahead or use the chapter markers down below that I included if you need to. You won't hurt my feelings by skipping. After the D1 Mini's soldered up, I ran the buck converter out to the power rails on the side of the breadboard. Then added the servo motor leads. As a side note, when you're soldering, try not to breathe those fumes in. It's not very good for you. They actually make little fans for that, but I haven't gotten one yet. I kind of have a habit of just exhaling while I'm soldering. This yellow wire is the pulse width modulation, the PWM signal wire for the servo. I could have just ran the jump wire directly to the pin on the D1, but I figured this looks nicer and it seems like a little more cleaner install. And now to attach the ultrasonic sensor. For voltage, make sure you use the 3.3 volts. And pay attention to what pins you're using for the trigger and echo signal wires. You'll need to know them when you add the ultrasonic sensor to the ESPHome YAML file in just a minute. Now to power the D1 Mini, I'm running a positive and a ground wire from the power rail. I tested the servo and home assistant again now that it's soldered up on the breadboard, and later realized that I had the wrong pin for the PWM pin on the D1 Mini. I'm using D4 now, not pin D1, so oops. Oh well, easy fix. After another quick flash, I'm back in business. For attaching the servo motor to the flappy wheel, or at least that's what I'm calling it, the flappy wheel, I just melted a hole in the center with my soldering iron, and then I pushed the servo sprocket into it while it was still hot and soft, and then the plastic molded around the teeth on the sprocket and it fits perfect. And another side note, try not to breathe in those fumes either. To mount the servo to the food dispenser, I drilled out 4 holes that lined up with the servo and then ran some bolts through the inside. I'd recommend using thread locker or like Loctite on them just to prevent loosening, because you don't want to over tighten them. The food dispenser's plastic and it'll probably crack if you over tighten them. It's pretty hard and brittle. This was kind of a pain. I kept on dropping nuts. And then later I realized I can't put the container in the holder with the servo attached to it, so then I had to take it apart and then put it back together with it in the container. But at least I got to test it out. And some final assembly here. I hot glued the buck converter to the breadboard just to keep everything all together. Then to support the AC adapter cable, I just ran a zip tie through the hole on the breadboard and tightened it up. To attach the circuitry to the food dispenser, I just used some Velcro tape I had kicking around in my junk drawer. It seems to work pretty good, and it's removable if I need to. Oh, and on a side note, do you guys have a junk drawer at your house? Or is that just a Wisconsin or Midwest US thing? Let me know down in the comments if you want. Here I'm plugging in the servo wires. And now it's time to get the ultrasonic sensor taken care of. I just kind of eyeballed where I thought the hole would work best and then drilled a hole to run the wires through. This ultrasonic sensor fits perfectly under the lid. It's like the lid's made for it almost. A little more hot glue to seal the hole, keep the dust out, and hopefully keep the cat food a little fresher. Back on the computer, in order to add support for the ultrasonic sensor, just go to the ESPHome website and click on Sensor Components. And you should see the ultrasonic sensor in the list. Just paste that code into the ESPHome file, update the trigger and echo pin assignments to what you're using, and give it a friendly name that you want to appear in Home Assistant. And you can also add a update interval to if you wanted to update other than every 60 seconds like it does by default. To have it feed my cat a daily ration, I had set up an automation. I played around with the servo set points until the dispensed amount was around 3/4 of a cup of food, like vets on the web when I was searching recommended. To determine at what value I wanted an alert to be triggered when the reservoir was low, I rotated the servo when it was empty through the whole range, and then the graph on the bottom is actually the flappy wheel going around. So it seems like 0.2 meters from the lid is a good place to start as far as an empty alert. And I also set it to alert me over my Nest mini speaker in the living room and send me a notification on my phone with the current measurement too. And here's the moment you've all been waiting for. Time to plug it in and test it all out. I made kind of a mess when I was dialing in the servo, but it really doesn't miss the bowl that much. The trick seems to be to have your automation rotated a portion of the way and then go back to a start point. And that way it seems a little gentler. And as an unexpected bonus, my cat Shelby now has mood lighting for dinner too. I'm making these videos for you. So if you have any comments or questions about what I did, let me know down in the comments. And if you want to see more videos from me like this, be sure to click like and subscribe. And remember, everybody's a little weird, but there's only one you, so be yourself.